Welcome to physics class. In today's video, we'll be concentrating on the conservation of linear momentum. We'll be dealing with Newton's second law of motion and also third law of motion. Let's begin. Consider two bodies of different masses moving in the same direction. So we have body MA moving with a velocity UA, and then another body, let's call this one MB, moving with a velocity UB. Let's call this before collision. Before collision, then at collision, body A and body B, that is MA, MB, they collide. Let's call this at collision. As they move, they collide here. So for Newton's second law of motion, for every action there is an opposite but equal reaction, the negative sign here. So let's call this body MA after collision moves with the final velocity MA, and also body MB moves with the final velocity UB. Mind you, they all move in the same direction. So we'll call this one after collision. So before collision, at collision, after collision. Now let's begin. From Newton's third law of motion, which is here, we know that FA is equals to minus FB. Let's call this our equation number 1. Newton's second law of motion states F is equals to, now let's write, but F is equals to MA. Let's call this our equation number 2. So let's write FA is equals to A subscript capital A, and also minus FB is equals to minus MB A subscript capital B. So let's write. So this implies that A capital letter A is equals to minus MB AB. Let's call this our equation number 3. So we substitute. Okay, let's move on. But acceleration A is given as what? V minus U all over T. We call this our equation number 4. So we substitute equation number 4 into this equation number 3. But let's write. Take notes. Let A capital A equals to V A minus U A all over T. And then let AB minus AB be equals to minus into VA minus UA all over T. So we call this equation number 4A, equation 4B. Take notes. Let's move on. M A into VA minus UA all over T is equals to minus MB into VB minus UB all over T. This go. So you have MA into VA minus UA is equals to minus MB into VB minus UB. You open the brackets, so we have MA into you have MA VA minus MA UA is equals to minus MB VB plus MB UB. Call this equation number 5. From here, we go this way, equation number 5. So we collect like terms. So these are momentum before, momentum after, momentum after. Collision before, after collision. So we collect this and this together. So we have MAVA plus MBVB is equals to MBUB plus MAUA. We rearrange the equation to have it arranged properly. So we have bring this to side and then this to this side. So we have MAUA plus MBUB is equals to MAVA plus MBVB. Therefore, the law of conservation of mechanical energy is stated in this equation. Call this equation number 6. I will explain this equation and then in our next video we're looking at how to use this equation to calculate. Take notes. If two bodies are moving in the same direction before collision, you have a plus sign here. Mind you, when vectors are acting in the same direction, what do? You add the vectors. When vectors are acting in opposite direction, what do? You subtract the vectors. And so, if two bodies are moving in the same direction, you put a plus here. But if they are moving in opposite direction, what do you put? You put a negative sign here. And if after collision, they move in the same direction, you put a plus sign here. But if after collision, they move in opposite direction, what do you put? You put a negative sign here. Thank you for watching. In our next video, we'll be looking at how we use this equation to solve very, very related questions. Thank you and God bless you.